Hello guys, I want to do a very brief reminder video for you of one way that you can reduce a fraction to lowest terms, and we're going to show you how to do that by dividing both the numerator and the denominator by the greatest common factor. But first, can you tell me what is smaller than an ant's mouth? Well, what an ant eats. So, if we wanted to reduce a fraction to lowest terms, we're going to use the GCF, or the greatest common factor. So let's go ahead and say that we want to reduce 18/24 to lowest terms. What do we need to do? First thing that we need to do is find the prime factored form, or the prime factorization of both the numerator and the denominator, which means that we want to be able to write 18 as a product of factors, all of which are prime factors. So while it's true that we can say that 2 times 9 is 18, 9 is not a prime number, so we want to come up with the multiplication that will allow us to arrive at 18 without using numbers that are not prime. You remember how to use our factor tree? Think of two numbers that multiply together to equal 18. Once we end up with a prime number down here, 2 is prime, because the only way that you can arrive at 2 as a product is by saying this number times 1. That's a prime number, so we're going to circle it. 9 is not a prime number because you can say that 9 can be arrived at by saying 3 times 3. However, 3 is a prime number. The only possible way to end up with 3 as a product is to say 3 times 1. Once all of our circles here at the end of these stems are prime numbers, we have found the prime factorization of 18, and we can say that 18 is equal to 2 times 3 times 3. Okay? The number that we're reducing to lowest terms is 18/24. So we found the prime factorization of 24. Now, of 18. Now we want to find the prime factorization of 24. What two numbers can we think of that multiplied together give us a product of 24? Well, 2 times 12, 3 times 8, 4 times 6. Pick a number that comes into your head. I like to pick numbers that are closer to one another because then I usually have less branching to do. 4 times 6 is 24. Neither of these numbers are prime. So 2 times 2 is 4. The 2's are prime numbers, so I can circle them. What two numbers can I multiply together to get 6? 2 times 3. Both of these numbers, thank you, both of these numbers are prime, so I circle those. All of my bottom numbers are circled and prime numbers, so I've completely factored 24. And I have 24 is equal to 2 times 2 times 2 times 3. The prime factorization of 18 is 2 times 3 times 3. Is that really true? Well, 2 times 3 is 6. 6 times 3 is 18. None of these factors are composite numbers. They're all prime numbers. Prime factorization of 4. 2 times 2 is 4. Times 2 is 8. Times 3 is 24. All of the factors are prime numbers. So this is the prime factorization of 24. So we don't need our factor trees anymore. I'm going to erase them. I'm going to say that 18/24 is the number that we're reducing. And we know that it's not reduced to lowest terms because they're both even numbers. And all even numbers are divisible by 2. We also can notice that both of these numbers are divisible by 3. If we remember our divisibility rule that tells us that if we add up the digits, 1 plus 8 is 9. If we can take that sum and divide it evenly by 3, then you can also divide the number by 3. So 1 plus 8 is 9. 9 divided by 3 is 3. So this number is clearly not prime. 2 plus 4 is 6, which is also divisible by 3. So 24 is obviously not prime, which means that we have common factors here. We have to reduce this to lowest terms. The greatest common factor, what we're going to look at, here we're going to see how many factors we have in common. We have a factor of 2, and we have a factor of 3. For factors to be common factors, they have to show up in even pairs between this number here that we're reducing to lowest terms. We have a pair of 2's, and we have a pair of 3's by taking one member of each pair from each separate number that we're factoring. We have a 3 left over as a factor in the 18. We have 2 factors of 2 down here with 24, but it can't do anything else because we only have these 2 pairs. So our greatest common factor is the product that we get when we multiply together a 2 and a 3. 2 times 3 is 6. So how do you reduce fractions to the lowest terms using the greatest common factor? This is what you do. Let me grab a... I don't believe I have a good marker. What you're going to do is divide numerator and denominator by the GCF. If you want to use the GCF, the greatest common factor, to reduce a fraction to lowest terms, prime factor the numerator and denominator, multiply the common factors together to arrive at your GCF, and then divide both the numerator and the denominator by that common factor. 18 divided by 6, 24 divided by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. And we now have our fraction of 18/24 reduced to lowest terms. We reduced it to lowest terms by dividing by the greatest common factor. Okay? Now let's do one more. And I want to show you how we can use exponential notation to guide us when we are dividing or when we're reducing a fraction to lowest terms using the greatest common factor. Let's say that we want to write 60/90ths in lowest terms. And I'm going to tell you right now that 60/90ths reduced to lowest terms is a fraction 2/3. Okay, you can tell we can divide both the numerator and denominator by 3. We can divide it by 0, we can divide it by 5, we can divide it by 2. There's clearly some common factors in there. Let's go ahead and first find the prime factorization of 60. 60 can be written, and there are any number of ways you could do this. My factor tree just happens to be the way I'm choosing to do it. 6 times 10, 2 times 3 is 6, 2 times 5 is 10, and I now have 4 prime factors of 60, so my prime factorization is completed. Let's see what I have for 90 now. And I'm going to say 9 times 10 is 90. 3 times 3 is 9. Both of those are prime. 2 times 5 is 10. And both of those are prime. Now what I showed you before is that if we want to reduce a fraction to lowest terms using the greatest common factor, first we prime factor each number and write that as a product of primes. So 60 is equal to 2 times 2 times 3 times 5. 90 is equal to 2 times 3 times 3 times 5. This is what we did last time. I want to use exponential notation, but before I do that, let me calculate what the GCF is going to be, just keeping this in expanded notation, using no exponents. What factors do I have in common? Well, I have one pair of 2's, and I have a pair of 3's. And I have a pair of 5's in common. So I have 2 times 3 times 5. Greatest common factor is 60. And as it occurs here, I didn't pick a really perfect example to show you, but I'm going to use it anyway. If we wanted to go ahead and use exponential notation here, 60 would be written as a product of primes, 2 squared times 3 times 5. Remember, when we use exponential notation, this indicates that the number 2 is used as a factor how many times? Twice. 3 is used as a factor once. 5 is used as a factor once. And what is 90? 90, 2 is used as a factor once. 3 is used as a factor twice. 5 is used as a factor once. Now when you find your greatest common factor, what you do is you use each prime factor that appears in both factorizations, but you use the smallest exponent. We have the 2 squared, 2 to the first, so we only use one of those factors of 2, one of those factors of 3, and one factor of 5, which tells us that the GCF is 30, and I think I said 30 correctly before. 2 times 3 is 6 times 5 is 30. Sorry about that. We've found the GCF is 30. We're going to divide the numerator and the denominator by 30 to find our reduced fraction of 2/3. Using exponential notation really comes in handy if you have like 4 factors of 2 and 3 factors of 3 and 2 factors of 5. It just makes it a more concise, more manageable way to indicate those factors. So this is what you do to reduce a fraction to lowest terms using the greatest common factor.